This is page 20. Page 20 in your physics textbook. And we're going to do questions number 11 and 12. I'm going to do 12 first because 12 is actually a little easier and it will help you with 11. And so here's question 12. Spotting a friend 5 meters directly in front of you, walking 2 meters per second north. You start walking at 2.25 meters per second north to catch up. How long will it take for you to intercept your friend, and what will your displacement be? So with all these questions, we're going to start with a sketch. So here's a sketch, and the sketch is usually a DT graph. Your friend starts 5 meters in front of you. So let's say that you start at the origin. So there is you, and your friend is starting 5 meters in front of you, and he's walking slower. So this is what you're going to, your friend is going to look like that approximately. And we know that this value here in terms of the displacement for the distance is 5 meters. Okay, so a good sketch is going to help you out a lot. And the question is asking, at what time and distance will you meet? And you can see that this is the intersection point. And so we're looking for that time and this displacement. And there are many ways to do this, but I find the best way to do it, the way that I like to do it, is just using a DVT chart. Here's you, here's your friend, and we're just going to fill in this chart, and then we're going to use that information to solve the problem. So what do we know? Well, the only thing that we know for sure, in terms of definitive values, is that you are walking at 2.25 meters per second, 2.25, and that your friend is going a little slower at 2 meters per second. 2. So that we know for sure. What do we know about the time that you meet? Well, absolutely nothing. We have no information about the time. What do we know about the displacement when you meet? This value right here. Well, again, we don't know anything definitive, but we do know that your friend is going to end up traveling 5 meters less than you, right? If this is the distance, distance your friend is going to travel. And I'll do it in yellow here, is the distance that you are going to travel because you're starting at the origin. So you're traveling a greater distance. So although we don't have definitive numbers, we do have a relationship in the displacements. And you can say, so what we're going to do is this blue bracket that I drew in the yellow bracket, we're going to give one of them a value of x. And then the other one, we're going to say, we're going to write an expression for it. So probably the easiest way to do this specific question is, let's say that this blue bracket here is x. And that is the friend that is the distance, the displacement that your friend has traveled. So he gets a value of x. And then you ask yourself, what is an expression for the distance that you have traveled? And clearly, since you started 5 meters before, in front or behind him, you are traveling 5 meters more than he is traveling. So an expression, not a value, but an expression for your distance is going to be the distance that he traveled plus the extra 5 meters that you traveled because he's 5 meters in front of you. So now at least we have expressions for the displacement. And now we're going to go over to the time. And again, we don't have any specific information, but now that we have an expression for the distance and the value for the velocity, we can use v equals d over t. And we can rearrange that formula for t. T equals d over v. And we can write now an expression for the times right over here. So the expression for your friend, let's do your friend first because he's a little easier, is displacement over velocity. So that would be x over 2. And an expression for the time that you have traveled is going to be your displacement, x plus 5, over 2.25. And now you can go back to your graph here and look at your graph and say, well, what can I say? What generalization can I make about the times that you and your friend have been traveling? Well, you both started at the same time. You both started at 0. So therefore, the amount of time that both of you have been traveling is equal. And that is the key to solving this problem. Once you acknowledge that the time that both of you have been traveling is equal, then we can take these values here and equate them, set them equal to each other, and solve. So we're going to go x plus 5 over 2.25 equals x plus 2. And now, as in math class, you have an equation with a single variable, and we can go ahead and solve that equation. The best way to solve this equation for x is start by cross-multiplying. You can do that anytime you have fractions on either side of an equal sign. You can cross-multiply. It's just a shortcut method to multiplying both of them by the lowest common denominator, or multiplying both of them by 2.5 times 2. So you cross-multiply, and you get 2.5x equals, and be careful here, make sure it's 2, and then you have to have the brackets. You can't just go 2x plus 5. It's got to be 2 times x plus 5. And then solve this as you would a normal equation. Distribute the 2. Distribute 2x plus 10. Get all the x's over to one side. So let's move that 2x over there by subtracting 2x on both sides. Subtracting, leaving us with, oops, sorry, that should be 0.25 x equals 10. Divide both sides by 0.25, and you end up getting x equals 40. 10 divided by 0.25, or 10 divided by a quarter, is x equals 40. Okay, and then be careful, because that's not the answer to the question necessarily, because you have to go back to your chart, or your table here, and what's the value of x? It's this one right here. It is the x is right there. That is the distance that your friend traveled. So in other words, your friend traveled 40 meters. You traveled 45 meters. And to get the time values, you're going to take that value of 40 and you're going to plug it in right here and here. You only have to plug it into one, really, because you know that the time is equal for both of them. But if you plug 40 into this one down here, which is obviously the easiest one, you get 20 seconds. This is 40 meters. This is 45 meters. So then you're going to have to write the answer to the question in a sentence form, and the answer to the question is you will meet in 20 seconds. At that point, your displacement will be 45 meters. Your friend's displacement will be 40 meters. How are we doing? 8 minutes for that one. Okay, let's do this. Let's actually I'm going to stop and make a separate video for number 12 or number 11. That way you can just watch either one.